bisect array bisect algorithm. Source code lib bisect py. This module provides support for maintaining a list in sorted order without having to sort the list after each insertion. For long lists of items with expensive comparison operations, this can be an improvement over linear searches or frequent resorting. The module is called bisect because it uses a basic bisect algorithm to do its work. Unlike other bisect tools that search for a specific value, the functions in this module are designed to locate an insertion point. Accordingly, the functions never call an equal method to determine whether a value has been found. Instead, the functions only call the less than method and will return an insertion point between values in an array. The following functions are provided: bisect.bisect underscore left a x lower 0 high length of a star key is equal to none. Locate the insertion point for x in a to maintain sorted order. The parameters low and high may be used to specify a subset of the list which should be considered. By default, the entire list is used. If x is already present in A, the insertion point will be before to the left of any existing entries. The return value is suitable for use as the first parameter to list or insert, assuming that A is already sorted. The returned insertion point IP partitions the array A into two slices such that all element less than x for element in A low colon IP is true for the left slice and all element greater than equal to x for element in A IP colon high is true for the right slice. Key specifies a key function of one argument that is used to extract a comparison key from each element in the array. To support searching complex records, the key function is not applied to the x value. If key is none, the elements are compared directly and no key function is called. Bisect underscore right a x low 0 high length of a star key is equal to none. Bisect a x low is equal to 0 high is equal to length of a star key is equal to none. Similar to bisect left but returns an insertion point which comes after to the right of any existing entries of x in A. The returned insertion point IP partitions the array A into two slices such that all element less than equal to x for element in A low IP is true for the left slice and all element greater than x for element in A IP high is true for all for the right slice. Bisect dot insert underscore left a x low is equal to 0 high is equal to length of a star key is equal to none. Insert x in a in sorted order. This function first runs bisect underscore left to locate an insertion point. Next, it runs the insert method on a to insert x at the appropriate position to maintain sort order. To support inserting records in a table, the key function, if any, is applied to x for the search step but not for the insertion step. Keep in mind that the O log n search is dominated by the slow O n insertion step. Bisect.insert underscore right a x low is equal to 0 high is equal to length of a star key is equal to none. Bisect.insert a x low is equal to 0 high is equal to length of a star key is equal to none. Similar to insert underscore left but inserting x in a after any existing entries of x. This function first runs bisect underscore right to locate an insertion point. Next, it runs the insert method on a to insert x at the appropriate position to maintain sort order. To support inserting records in a table, the key function, if any, is applied to x for the search step but not for the insertion step. Performance notes: when writing time-sensitive code using bisect and insert, keep these thoughts in mind. Bisect is effective for searching ranges of values. For locating specific values, dictionaries are more performant. The insert functions are on because The logarithmic search step is dominated by the linear time insertion step. The search functions are stateless and discard key function results after they are used. Consequently, if the search functions are used in a loop, the key function may be called again and again on the same array elements. If the key function is not fast, consider wrapping it with functools.cache to avoid duplicate computations. Alternatively, consider searching an array of pre-computed keys to locate the insertion point as shown in the example section below. See also sorted collections is a high performance module that uses bisect to manage the sorted collections of data. The sorted collection recipe uses bisect to build a full featured collection class with straightforward search methods and support for a key function. The keys are pre-computed to save unnecessary calls to the key function during searches. Searching sorted list. The above bisect functions are useful for finding insertion points but can be tricky or awkward to use for common searching tasks. The following five functions show how to transform them into the standard lookups for sorted list. Diff index ax, locate the leftmost value exactly equal to x. I is equal to bisect underscore left ax. If I not equal to length of a and a of I equal to x, return ai raise value error. Diff find less than ax, find rightmost value less than x. I is equal to bisect left ax. If I return a of I minus 1 raise value error. Find less than or equal ax, find rightmost value less than or equal to x. I is equal to bisect right ax. If I return a of I minus 1 raise value error. Find greater than ax, find leftmost value greater than x. I is equal to bisect underscore right ax. If I not equal to length of a, return a of I raise value error. D, find greater than or equal to ax, find leftmost item greater than or equal to x. I is equal to bisect left ax. If I is not equal to length of a, return a of I raise value error. Examples. The bisect function can be useful for numeric table lookups. This example uses bisect to look up a later grade for an exam score, say based on a set of ordered numeric breakpoints. 90 and up is A, 80 to 90 is B, and so on. Diff grade score breakpoints 60, 70, 80, 90. Grades F, D, C, B, A. F, D, C, B, A. I is equal to bisect breakpoints score. Return grades I. Grade score for score in 33, 99, 77, 70, 89, 90, 100. F, A, C, C, B, B. Bisect. Bisect. Example from import bisect dot bisect grade for a print grade of score for score in 33, 99, 77 this grade FACCBAA. The bisect and insort functions also work with lists of tuples. The key argument can serve to extract the field used for ordering records in table from collections. Named tuple, movies, release, sort, bisect. Example 2. Is equal to result print result. Movie name is equal to The Birds, released is equal to 1963, director is equal to Hitchcock. Collections name tuple operator aggregator bisect insert from pprint import pprint. Movie name tuple movie name released director movie Jaws 97 Spielberg Titanic this. Find the first movie released after 1960 by year aggregator ag- attribute aggregator release movies dot sort key is equal to by year release is equal to this. Print by year released. Okay. Insert a movie while maintaining sort order. Romance insert movies romance print movies. Insert a movie while maintaining sort order. Romance is equal to movie love story 1970 Hiller. In short, movies romance key by year. Print movies 1970, 75, 86, 1963. If the key function is expensive, it is possible to avoid repeated function calls by searching a list of pre-computed keys to find the index of a record. Data is equal to this red 5 blue 1. Data dot sort key is equal to lambda r of 1. Data is equal to red by test red blue this. Data dot sort key is equal to lambda r your huge operator dot item getter 1. R flag 0. Data dot bisect left keys is equal to 1. Result is equal to bisect. Print result is 1. Blue 1. visit to this and